Hello friends, good morning or good evening wherever you stay. So let's wait a couple of minutes before we start. Let's wait for some people to join at least. As of now, no one have joined yet. So I'm in the meantime, I'm starting my cluster on which I will be demonstrating today's session, and then we will start. Okay, so a few people have joined. Yes, we have just started, Rocky. Okay, and also good afternoon to Ravi. And so we'll start now. So the agenda for today's session, let me share my screen. And if you want to ask Q&A, wait until the end of the session. And also make sure you connect through event page to ask the Q&A. I will be pasting the event page link on the YouTube video also. If some people are watching this video through YouTube directly, if they put comments in YouTube under YouTube link, you will not be able to. I will not be able to see those questions, and I will not be able to answer those. So let me paste the event link, and then we will start. So this is the event page which you need to connect to ask Q&A. This is the event page. Okay, so if people want to, if people are watching on YouTube and if they want to ask question, come to the event page and you can ask the question towards the end of the session, and I will be able to answer those things. Okay, now let us start the session. Today's agenda is, first we will try to understand a little bit about itversity, and then we will get into the main agenda, which is about the big data cluster configuration, how it looks like in production clusters. Okay, so about itversity. itversity is a one-stop shop to learn all the technologies, and also we want to get into staffing solutions also as phase 2. As part of phase 1, we will just focus on uploading content in emerging technologies and also evergreen technologies such as Oracle, etc. In emerging technologies, we will be focusing on big data, cloud, and many other things over time. Okay, and we typically provide. We have a YouTube channel called itversity. You can go to YouTube and search for itversity, and it will take you to this page. And you can see there is a lot of content. There are almost 825 videos covering big data predominantly at this time, but we'll be focusing on other areas also. On top of this channel, we also have a website called www.itversity.com. As of now, only 2 or 3 courses are live under self-paced courses, but eventually there will be a lot more courses. We will be providing platform for people to blog the technical blogs so that people can actually get some traction to their profile, etc. And also make sure you stay connected with me on different platforms. You can subscribe to YouTube. The screen share is stopped. Let me share my screen again. Okay. So you can subscribe to my channel. You can follow me on LinkedIn page. You can follow on Facebook page. You can follow on Twitter, Google Plus, etc. So and we will be conducting many hangouts in emerging technologies, not only in big data, cloud, in many other areas. So we'll be glad to have you also to be part of these hangouts. Few people are already showing interest to talk in hangouts. We can review the agenda and we can see if it adds value to the people. I can accommodate a few more speakers as part of the hangouts, and also people can start blogging. For blogging, you have to wait for some more time. I'm planning to redesign my website so that it is blogger friendly. But I would like to provide a platform where people can publish the articles and it is shared widely in LinkedIn, where you can extend your professional network with good contacts. That being said, now let's go on to the agenda quickly. So first we will see what is big data, Hadoop, and distributions. Big data is primarily to manage huge volumes of data with some variety, such as structured as well as unstructured, and also with good velocity. So I don't want to get into too many details with respect to big data at this time. You can go onto my channel and search for big data introduction, and you can see many videos on that topic. You can understand what is big data all about. But from today's perspective, what big data is, it's nothing but group of technologies. It not only includes Hadoop, it has many other technologies which facilitate you to build the cluster to process huge amounts of data. Okay, so I have started my cluster. So let me connect to gateway node on my cluster. So this is my cluster, which is managed by Cloudera distribution. If it is managed by Hortonworks distribution, it will look a little bit different. I will show a sample Hortonworks distribution also. A sample Hortonworks cluster also. Just give me a minute. Ambari, yes, this is the one. Okay, so this is the Hortonworks cluster. You can see there are many tools that are configured as part of this cluster. And as part of my Cloudera cluster, there are only few items. I don't have everything, but I have few items. But when you actually set up the cluster, you not only set up Hadoop, HDFS, and Yarn. There are many other things which you need to focus on. Okay, I will get back to those things in a moment. So if I want to add new service, let me delete Impala here. I will take care of it later. Anyway, if you click on add a service on Cloudera cluster, there are many components here. All these are considered as part of big data ecosystem. Hadoop is only part of it. Hadoop is not completely big data. There are many other things which you need to keep in mind when you are trying to set up the cluster. So you have HDFS, Yarn, Hive to provide SQL type of interface. If Yarn is not or MapReduce is not actually working for you, you have Spark to process data in memory, which is supposed to be much faster than MapReduce based solutions while processing a good amount of data. Because it processes in memory, it is faster, but it takes a lot of memory while processing using Spark. On top of that, you need to ingest data into Hadoop from several sources. One of the source could be a relational database. So for that, you have Scoop. Scoop is the technology which you can use to connect to the source database and get data into Hadoop big data clusters. And if you want to get data from weblogs, then you have Flume and Kafka. So here you see Flume and also Kafka. Kafka is another technology where you can ingest data into many targets. One of them could be our big data cluster. So these are all called as services. So big data ecosystem is nothing but services. Under Cloudera, it is called as I think Cloudera Data Hub, and in Hortonworks, it is called as Hortonworks Data Platform. So when they say Hortonworks Data Platform or Cloudera Data Hub, they're actually talking about all the technologies which they are providing as part of their distribution. It includes Solr also if you want to store data in indexed format, and if you want to build applications on top of it. Now Cloudera distribution supports Solr also. So these are all called services. And these services have to be deployed on the cluster. Okay. So as of now, I have only few services such as HDFS, Hive, Impala, Yarn, etc. I don't have all the services which are available as part of add a service. I have only limited ones because those are enough for my cluster. So when you actually set up the cluster in true production environment, first you need to think about what are the services you need to deploy, and then you have to add all those services. okay, as part of the cluster. That is the first step which you need to keep in mind. What services you should have so that you can build applications using those services. So for example, if you want to build Spark based application, you have to have Spark service deployed as part of the cluster. And if you use Cloudera distribution or Hotnox distribution, you can have it out of the box of Cloudera or Hortonworks as a service. And then comes the capacity planning. So depending upon what type of applications you want to build, you will decide on the services. And depending upon how much amount of data you want to store in Hadoop, and also how much amount of data you want to process on daily basis, drives the capacity planning of your cluster. Our big data cluster planning is driven by the storage amount of data that needs to be stored in the cluster, and amount of data that needs to be processed on regular basis. Those two are significantly different. I have worked on projects where you have petabytes of data, but you only process few gigabytes of data on daily basis. And then I have seen other projects where you have only few terabytes of data, but you process quite the data multiple times, quite a bit, and hence the processing power that need to be there to process a few terabytes of data is much higher than the project which I have worked on petabytes of data. So two things drive the big data cluster planning: storage and processing. If it is storage driven, means if you are not processing too much, it is IO bound. If it is processing driven, it is CPU bound. So depending upon type of applications you want to deploy, whether your cluster want to be supporting IO bound applications, you need to come up with a different type of cluster configuration. For CPU bound, you need to have different type of cluster configuration. And then so you have multiple services, and each service have a different architecture. I will touch base few services here. So for example, you have, let me take this Ambari cluster because we have a lot more services. So we have HDFS. If you click on HDFS have name node, secondary name node, and data nodes. And data node is running on 7 nodes in this cluster. Similarly, if you look into HBase, it has active HBase master and standby HBase master. And then only 2 region servers are there in this cluster. Typically, region servers will be running on all the data nodes. So ideally, it should have 7 region servers, not just 2 in this cluster. But this is for lab, so things might not be similar to in production. But if you look into Hive, here you have Hive Metastore, Hive server, and WebHCat server. But you have 7 Hive clients, which means that couple of servers have the masters, and rest of them are clients. Whereas in HDFS, you can see data nodes are in green, which means that there are some slave process running in the cluster. We'll get into the details in a moment. The point which you need to take from this is that you need to understand each and every service architecture. Okay, whether it have master and slave architecture or it have client only architecture. Depending upon that, you have to make the decisions about your cluster configuration. For example, Scoop is purely client only. It will not have any masters that will be running. So you don't need to worry much about the resources that needs to be allocated for Scoop. Scoop uses HDFS for data, storing the data, and MapReduce to process the data. That being said, first you need to identify the services. You need to understand the architecture of the services. So I will open a spreadsheet here. Okay, let me zoom in a little bit. I don't know why it is not being. Okay, let me zoom from here 150%. So you have services. Okay. You have masters, workers, utility or edge or gateway. Okay, workers or slaves. Okay, so services are, you have HDFS, Yarn plus MapReduce 2, Hive, Spark, HBase, Impala, and many more. You have many more. So for each of them, you have to understand whether it requires masters. So HDFS require at least 2 masters. One is for name node and secondary name node. Or for active passive configuration, you need to have at least 2 masters. For HDFS, you need to have 2 masters. For Yarn, typically earlier there was no high availability for job tracker. Or people not used to use high availability as part of Hadoop 1, where we have MapReduce Classic, where there was no Yarn. But now it is typical that they set up high availability for Yarn also, or resource manager, which is the master in Yarn. Okay, and then Hive. Hive just have 1 or 2 masters, which will run Hive server, Hive metastore, etc. And then Spark. Spark depends upon whether you want to use it with Yarn or not. It differs. So here, Spark. Let me put the comment section here. Spark can use Yarn, and let us assume that we want to configure Spark with Yarn only. Don't think that we will use Spark native native job execution framework. We will use Yarn itself to execute the Spark jobs also. And then HBase typically will have 3 masters. Okay, because high availability on HBase is much more important than HDFS. Because if HBase goes down, some of the live applications can go down. So for that reason, we need to have 3 masters. Okay, and then Impala, again, we need to have 1 or 2 masters. And depending upon other services we have on the cluster, we have to define what are the masters we want to use. So for Hive also, let us take, we will configure only 1 master. For Impala also, let us take, we want only 1 master. And also we will take another example, Kafka. Okay, Kafka typically will have 3, you can term it as masters or utility nodes. It is interchangeable for tools like Kafka, because they are not primarily Hadoop based tools, but they can actually pump data into Hadoop also. So let us configure it as let us say that we'll configure 3 Kafka servers to push data from web logs into Hadoop. Okay, and then if you add all these things, C2 to C8, so we need 12 masters alone. So we, on a cluster, we need to have 12 masters. So again, when it comes to masters, the memory configuration, CPU configuration might vary, but typically we will homogenize and we will try to use similar configuration for all the masters. And then comes slaves. Okay, slaves will be shared. Typically, masters will not be shared with each other. Each master will be will be running on different physical servers. So there is a possibility that all these 12 software services runs on 12 different physical servers. So two of the physical servers will be running HDFS masters, 2 of the physical servers will be running Yarn, 3 of the physical servers will be running HBase, and 3 of the physical servers will be running Kafka, and there won't be overlap between these, except for Zookeeper. Others will be running on their own masters. So here in this cluster, in a production size cluster, it is typical to have these many masters or utility nodes as part of your cluster. And then come slaves or workers. These will be typically shared. So first, let us understand what all will be sharing the slaves. Okay. will share slave. Okay, so HDFS, yes. So there will be data node running on each of the node. Yarn, yes, there will be node manager which will be running on each of the slave or worker node. Hive, no. Spark, yes, it has to run, but it uses Yarn internally. So as we are actually using Yarn, Spark also will be covered under node managers itself. Okay, and then HBase, yes, it is not managed by Yarn. You have to have region server on each of the node. Impala, yes, you need to have Impala D on each of the node if you want to set up Impala. Kafka is just a gateway utility to push data into Hadoop, or master utility to push data into Hadoop from weblogs. So it will not share any daemon process on the slaves. Okay. Now let us say that we want to configure a 18 worker node cluster. Okay. So on all the 18 nodes, you will have HDFS data node running. You will have node manager running. Nothing will be running for Hive. Spark will be under Yarn, so you don't need to worry about it. HBase, yes. Impala, yes. And Kafka, no. So the reason why you need to use these things are to actually configure your memory settings and CPU or vcore settings as part of the cluster. You need to understand these things, which will be shared on the slaves, which will not be shared on the slaves. So now we'll talk about the slave configuration. So I'm creating another section here. Okay, I will just. So let's say we have 18 slaves. Okay, so each slave, let's say it has 64 GB RAM. Okay, and let's say it have 16 cores or 16 cores. Okay, so you will provision hardware, and typically they will be pre-configured, and you will be buying those that hardware itself. So let's say we have the hardware in the organization which have 64 GB RAM and 16 cores and probably around 16 GB storage. Okay, so if you have not 16 GB, 16 TB, 16 terabytes of storage. We will have multiple hard disks, and I do not want to get into details at this time. Let's say you have 16 terabytes of storage on each of the node. So overall capacity of storage will be 16 into 18. Actually, I can say it here itself, equal to 16 into 18. So 288. 288 terabytes total storage. Okay, so with 1 minute, 16 into 18, is it correct? Yeah, it is correct, which means that you will be able to so you might be familiar with HDFS concepts already. There is a concept called replication factor. If you use the default value, it is 3. That means you will be able to store 90 terabytes of storage in this cluster. If you have 32 terabytes in each of them, then you will be having 576, which means that you will be able to store around 190 terabytes of storage on this cluster. Okay, so depending upon amount of storage you have, the amount of it will drive the amount of data that can be stored in the cluster. So for now, just focus on 288 terabytes of total storage and 90 terabytes of capacity that can be stored in the cluster. Now each slave have 64 GB RAM and 16 cores. Let me say 16 cores here. Okay, and 16 terabytes of storage. Forget about storage for now. These are the two things which you need to keep in mind when you actually set up each of the slave. For masters, you don't need to worry much. It's pretty straightforward to configure. You need to use you just let me take the master also. Each master Forget about storage. Storage is not that important for the masters, except for the gateway, which I will not be covering here. We will talk about gateway probably at the end of the session, or we will talk some other time. Okay, let's say each master also have this much of storage and memory and RAM. So you just have to take some memory out for OS, and rest of the memory you can give it to whatever component is running on that master. So for example, for HDFS, name node, give 8 GB to OS and use the rest of the 56 GB for name node. It's very straightforward. But when it comes to slave, as it shares with multiple things, you need to assess the impact of each of the component in the cluster. Okay, so now each slave have HDFS or data node, HDFS data node, yarn node manager, MapReduce, no need to worry, we will think about it later. Impala, Spark also uses yarn, so don't worry about Spark here. Impala D. Let's assume that Impala is not managed by yarn, and also HBase, region server. So these are the things which will be running on the same slave. Each of the slave will be having all these things. And then on top of that, you will have operating system. You have to have some operating system running on that. It will take some resources, right? And then you will have many other services. So sometimes we might have to have a mail server on each of the node in the cluster if your application have to send emails, or if you are trying to encrypt or decrypt the data, there are products which will be running on each of the slave nodes, which will encrypt and decrypt the data. So those other services also take some resources. So if you are planning to host those other services, you need to keep some memory aside for them. Otherwise, you can say you don't want to configure other services. For RAM, typically you will configure 4 to 8 GB RAM for OS. Okay, on the smaller size, with 16 GB, you will be using 4 GB. But once it reaches 32 GB or 64 GB, irrespective of the amount of RAM you have on each of the node in the cluster, you will hardly, you will give 8 GB. So with 64 GB, probably 6 GB might be good enough. Again, if there are some performance issues, then you might have to change these settings a little bit. But 6 GB is a good starting point for a slave node which have, or worker node which have 64 GB RAM. And then 1 core is enough for operating system. In some cases, you might have to give 2 cores, but 1 core is enough for operating system. Now, when it comes to data node, each data node, what is the role of data node? It just have to send heartbeat to the name node to tell that I am alive, or that a data node is alive. And also when the data is being copied, data node is the one which will write to the other data nodes to satisfy the replication factor. So it has some overhead, and it will be up and running all the time. So it takes some resources. So typically the default is 1 GB for data node memory, and that is enough. And it will take 1 core to keep the process up and running. That is also enough. And then yarn, you have node manager for yarn, which again does heartbeat to the resource manager to say that a particular node manager is alive. So again, it takes approximately 1 GB RAM. It does not actually process the data. It will only report that it is alive, and also it will facilitate to create mapper tasks and reducer tasks, or whatever containers that are required to process the data depending upon the execution framework you are using. If you are using Spark, it will process the data using Spark executors. Okay, but node manager itself will not execute anything. Hence, 1 GB RAM is enough for node manager, and 1 core is enough for node manager. And now comes Impala. You need to determine how many applications you want to deploy using Impala. Impala is memory intensive. So let's say you want not all applications in your cluster you want to use Impala. Hence, let's say you want to give 8 GB of RAM. Again, you have to do good good Sorry guys, it got disconnected. Now I'm back. You didn't miss anything. Luckily, it is disconnected accidentally. Okay. So now let me share my screen. Yes, I think you can see my screen now. So HBase region server we are talking about. So HBase region server requires some memory and it requires some cores. So here let us say we want to give 4 cores. So now after giving all these things, okay, so the RAM which is allocated for all the services including OS is 6 plus 1 plus 1 plus 8 plus 4. It is 20 GB. Out of 64 GB, we have allocated 20 GB for all these things. Out of 16 cores, we have allocated, let us take 2 only for simplicity's sake. Okay, and then seven cores are used for other purposes, such as for the supporting services purposes, and also for Impala and region servers. Now, after subtracting the 20 GB from 64 GB and also 7 from 16, you are left with 44 GB RAM on each worker node, and then 9 cores on each worker node, or 9 CPUs or 9 cores. Typically, the cores, the 16 cores will be like 4 quad core CPUs or 8 dual core CPUs, something like that. Okay, or 6 octa core CPUs, which means that you will have 48 cores. So you will not get the cores directly. The cores has to be multiplied with number of CPUs and the number of sockets you have for each CPU. So I'm now logging into the cluster. Okay, you can run lscpu command. If you have root permission, you will be able to see number of CPUs you have on each node, and also how many sockets you have. So in this case, there are 4 CPUs and there is 1 socket of 1 core per socket. So I have 4 cores on each of the node. And then my Cloudera based cluster, you can see here, if I go to hosts, click on all hosts, you can see there are 7 nodes in this, and only 4 nodes have data node, yarn, Impala daemon, etc. The other 3 are masters. So in this configuration, the topology is I have 3 masters of gateways and 4 data nodes. But the example which I have shown here, we are having 12 masters, or 12 masters and gateways, and then 18 slaves or worker nodes. Okay, so as we have 18 slave nodes in the cluster, our total capacity should be, when we actually log into the resource manager web interface, for that I have to enable SSH tunneling because I'm using AWS. So I'm using another tab here. Okay, tools, Foxy proxy. And then I'm using, I think this is the one which is running the resource manager. So to get the resource manager, you can go to here and then 808 is the port number. It will take you to the resource manager interface. So here, if I am running on 18 node cluster, 18 worker node cluster with this configuration, if I configure it properly, the RAM should be reflecting this one, 44 into 18. Okay, so 792 GB should be the RAM on my cluster. So this is total memory for all the worker nodes that is configured for yarn. Okay, and then the vcores is, so we have 18 nodes, right? So 18 into 9 into vcore multiplier. So from where we get the vcore multiplier, depending upon the type of applications you want to run. If it is IO bound application, which means that you store huge amounts of data but do little processing, you can have vcore multiplier as 4. If it is completely CPU bound, which means you have fewer terabytes of data but still you are doing a lot of processing on the data, which is CPU bound, you have to use vcore multiplier as 1. I will explain you why that vcore multiplier play an important role. So let us assume that we want to have mixed load and I want to give vcore multiplier as 2. If I configure properly, I'll be seeing vcore total as 324 here and memory as 792 GB here. Okay, if after subtracting all the services, if you are not getting similar values here, that means you have not configured your cluster properly. Okay, Now let us understand the logic behind vcore multiplier. Why we need to have 4 as vcore multiplier for IO bound applications and 1 for CPU bound applications. So if you are familiar with the way computers work, okay, so they typically storage will be in hard disk, and the processing will happen in memory by CPU. CPU will copy the data from hard disk into the memory, and then processing will happen. So the portion of copying data from hard disk into memory is called as IO. When IO happens, CPU will just send the IO request, but it does not do the IO. IO will be done by the IO handlers. Okay. When IO handlers is copying the data from storage into the memory, CPU can work on other things. For example, here if I go to the node and if I run ps-ef command, okay, we have only 4 CPUs or 4 cores in this. But if we say ps-ef, which will give all the process that are running at this time on the host, and if I do wc-l, which will give me the count of process that are running, there are 173 of them, but not all of them might be active at any point in time. Okay, some of them will be in the sleep mode because of IO or for whatever reason. So in case of IO bound applications, CPUs will not be used as extensively as CPU bound. That's why we can increase our vcore multiplier to 4. Okay, the bottom line is, when you try to process the data at full capacity, none of the processes should be going back and forth between sleep and active. The context switch between sleep and active mode should not happen. In case of IO bound applications, it will reduce quite a bit. Even though you are configuring your cluster to a lot more CPUs or virtual cores than the physical cores, still it will work fine. But in a CPU bound application, if CPU being used extensively by all the processes that are running at the time to process the data, then the context switch can become costly, and you will see the throughput going down. So identifying the vcore multiplier is very, very important, and also it's not straightforward, and that can make huge difference for your cluster performance. So that's where the vcore multiplier comes into picture. In this case, we are assuming that it will be mixed load. So let's assume that we will have 2.5. So you have 405 cores and 792 GB RAM that can be configured for yarn. And how these things can be configured? So first you need to understand the architecture. Okay, to process the data, remove Impala and HBase from this. Yarn can be used for both MapReduce as well as Spark jobs, and many other things might come in future. Even Impala might be plugged into the Yarn. Yarn might have insight about resource utilization from Impala. So the purpose of Yarn is, it's a generalized framework which can not only understand MapReduce but also other execution frameworks. Okay, so first we need to deal with Yarn, and we have to configure for each node how much memory and how many cores we should give for Yarn or node manager. For that, depending upon the distribution you are using, the interface will be a little bit different. Here I will be demonstrating using Cloudera. Even Ambari, it will be very straightforward. So first go to the Cloudera manager. Here we are talking about Yarn configuration. Okay, so click on Yarn. When you click on Yarn and go to the configuration, here you can search for node manager memory. Okay, and when you search for node manager memory, we will get into this resource memory MB. This is the most important one. But above that, you have, let me zoom in a little bit. You have Java heap size of node manager in bytes. So this is the one which will actually computed here. So this 1 GB which is given for Yarn node manager is controlled by Java heap size of node manager in bytes. Similarly, there will be a Java heap size of data node in bytes if you click on HDFS service and search for data node memory. Okay, and now this is the container. Container is the one which will actually create mappers or reducers or Spark executors to process the data. So here on each node, we are telling what is the highest amount of memory that can be managed by node manager. Okay, so we are telling what is the total capacity that can be controlled by node manager. So whatever containers that are created to process the data, whether it is Spark based containers or MapReduce based containers, the overall memory will not exceed 6 GB in this case. But in our case, we have 44 GB in each node in the cluster. So the overall capacity on each node should be 44 GB. In my case, I have only 8 GB RAM, out of which I have given 6 GB to node manager. But in the production cluster like this, you have to meticulously subtract the memory for all the other components and only use the remaining one to configure this very important parameter called yan.nodemanager_resource_memory_MB. Okay, so this should be configured to 44 GB for each node. Automatically, it is for each node. It's not the total, it's for each node. Similarly, for vcores, node manager vcores. So in this case, I have configured 4. In our case, we have to configure 9 into 2.5, or let's say 3. Okay, so total should be 486, and for each node it should be 27 vcores for each node. If it is completely IO bound, you can say 9 into 436, and this is the parameter which will control how many cores you should give while processing the data for all the containers that are managed by yarn, which includes MapReduce and also Spark. Okay, so this one will take care of yarn level settings, and also at container level also you can define what is the minimum memory and maximum memory. So node manager minimum. Okay, yeah, this one. So there are a group of parameters called an.scheduler.minimum allocation MB and maximum allocation MB. So these are, I will explain the logic behind these things. Okay, let me copy these things to here, and then I will explain. It is very important to follow this. Okay, similarly, minimum vcores, incremental vcores. I hope you understand what they're talking about. Minimum, increment, and maximum. Okay, here what we are trying to do is we are trying to set up what should be the minimum memory and maximum memory for the container depending upon the tool which you try to execute. It could be MapReduce framework, it could be Spark framework. So depending upon the framework we want to use, the containers which execute for example, if you take MapReduce, MapReduce will be run in the form of mappers and reducers. That is MapReduce technology. But from yarn perspective, they are nothing but containers. Okay, so here we are saying whatever framework we want to use, whatever underlying technology it uses, but at the container level, at the yarn level, the minimum memory that should be given for a container should be 1 GB as per this one. That is more than enough in most of the cases. And maximum memory is 4 GB, and incremental is, you can give either 512 MB or 1 GB, whatever it is. So let us take 1 GB as example. Similarly, we want to start with 1 vcore, and maximum I want to go for 3 vcores, and I want to increment by 1. So whatever task, if it is a MapReduce job, the mapper task and reducer tasks, we will configure the memories memory within 1 GB and 4 GB. We can give only between these values. We cannot give less than or greater than these minimum and maximum values. So here we are saying yarn to control the underlying frameworks to use this much memory for each container. Okay, and this will actually determine how many containers can run simultaneously. Okay, so now yarn is taken care. We have configured yarn. Let's say we have a similar production cluster, 18 worker nodes, where 44 GB is configured for memory and 27 vcores is configured for each node in the cluster. And then these are the settings for minimum and maximum allocations from memory as well as vcores perspective. Next comes the subcomponents of yarn. I will take only MapReduce as example. Similar steps needs to be followed even for Spark. Okay, so in this case, if you go to Cloudera Manager, you have yarn and MR2 together. They are not separated. But if you go to Ambari, for yarn level parameters, you have to go to yarn and click on configs and search for them. For MapReduce level parameters, you have to go to MapReduce and search for those things. Okay, so here I will take the example of Cloudera itself, and when it comes to MapReduce, the parameters will be let me get it from here. So MapReduce map memory MB. Okay, MapReduce map dot memory.mb. So memory.mb is given 0. There is one more parameter. So 0 means it will inherit the default values depending upon the configuration at higher level. There are other parameters also. Let me see. Map memory. Just give me a minute. I will get the parameter name. Yeah, those are the ones, memory MB and CPU vcores. You can leave it as default and it will take, I think, 1 core and 1 GB RAM for each of them. But if you want to customize, what you have to do is, you have to go here and you can only allocate within the range of 1 and 4 GB for map task, reduce task, and also application master. If you're familiar with the yarn framework, whenever you submit a MapReduce job in yarn framework, there will be application master for each job. So this parameter yarn.app.mapreduce.am.resource.mb will control how much memory should be given to that, and then MapReduce map memory MB and MapReduce reduce memory MB will be controlling how much memory should be given for map task and reduce task. Similar is the case with the vcores also. Vcores will be MapReduce map dot CPU.vcores. Okay, default is 1. You can give anywhere between 1 to 3. So as MapReduce is using yarn in this case, you have to satisfy the restrictions which are enforced by yarn on MapReduce. If you try to give 5 GB RAM for each of the map task and reduce task, then you will definitely run into out of memory issues or some other issues. So you have to satisfy the restrictions which are being enforced by yarn. So these are the restrictions which are enforced by yarn. So now what will be our cluster capacity? How much mappers will be executed or how much reducers will be executed? it will vary between time to time, because these parameters, the map reduce map memory MB, map reduce reduce memory MB, map reduce map CPU vcores, map reduce reduce CPU vcores, these can be configured for each job. So each job might be running with a different number of with different settings for map and reduce from memory and the CPU perspective, and depending upon that, the number of mappers and reducers that can run on a cluster will change time to time. Okay, so the ARM-based execution framework, especially for MapReduce, will give you a lot more flexibility compared to the classic. That being said, let me go to this article, ARM tuning. You should understand this one. This is a Cloudera blog post. This is primarily to tune the cluster. It does not furnish all the details which I have explained as part of this Hangout, but it gives a lot of similar information. And if you go through this one, you can see here, especially here, okay, what they're saying is, on a host, there can be multiple containers, and these containers might be running map tasks, reduce tasks, or application masters, or Spark executors. It could be anything. And each container can have different memory and CPU configuration. And depending upon that, your number of mappers and reducers, or number of tasks that can run at any point in time in your cluster, will significantly vary. Okay, so you cannot actually say that my cluster can run these many processes, because it varies depending upon the limits we have set and the configurations that are used while running the job. So once they are set, if you are trying to run a CPU bound job, probably you might want to give more cores to that job compared to IO bound job. Okay, that's how you should manipulate the amount of memory and the CPUs for each job while executing the job. So it gives a lot more flexibility to you to use the cluster effectively. And if we use the defaults, for example, let's say the map memory MB is 1 GB, okay, and map vcores, or let's say map reduce. Let's take both mappers and reducers. Okay. Here, if you say 1 GB, the reason why they set to zeros are, if you set to zeros, you can use whatever settings you want at the runtime, or it will, I think it will take default values of 1 GB, 1 GB. But if you can override at runtime if you set to 0. If you hard code those values, I think you cannot change it at runtime. I'm not 100% sure on that. Okay. Anyway, so let's take the example of having 1 GB memory for both map tasks and reduce tasks, and one core. Sorry, one core and 1 GB. Okay, now how much you have? You have 792 GB RAM on your complete cluster, and you have 486 vcores. Okay, so if you say I want to use 1 GB RAM and one core for each and every task that will be running on using MapReduce jobs, at the max you will be able to use on you will be able to run only 486 concurrent tasks for all the jobs, which means that you will be using only 486 GB. So rest of the memory will be wasted. So while running the jobs, you can get onto the hosts on the worker nodes and run top and see how much memory is being used. In a well-configured cluster, if you are running jobs with efficiently, you should be using 90% of the RAM at least. Okay, in this case, I am using 7.5 GB. I have only 8 GB capacity, so it is fine. But when the cluster is busy, the CPU should be at least 60%, 70%, and also memory should be at least 90%. Then only you have configured your cluster properly. Otherwise, you haven't configured your cluster properly. So in this case, your CPUs will be throttled when it reaches 486, but you will be wasting 30% of the memory unnecessarily. So for that reason, you have to understand at your application level, how much memory should you use and how many vcores you should use, and make sure that as much of memory out of 792 is used, and also as many of cores from 486 used when the clusters are busy. That is how you should plan your cluster. You should start from the topology. You should identify what should be the services that will be running, and you have to think about whether your cluster is will run workloads that are CPU bound or IO bound, and then you have to determine how much memory should be given for OS, for other daemon process such as data node, node manager, etc., which will be up and running all the time. You have to keep enough memory for those things aside, and then remaining memory should be configured at the yarn level, which will enforce the usage of memory and CPUs at the underlying components which are managed by yarn, such as MapReduce and Spark. Okay, so this is how you should build your cluster. If you are already working on the cluster, make sure it is configured properly. Review these parameters. It will give fair understanding about what I have discussed. And that being said, we have covered everything. Now I will take the Q&A. So I'm going to the event page. Let me open the Q&A here, and you guys can start asking questions. Sorry for the loss of connection in between. It is due to my internet provider disconnected as I didn't pay in time. Immediately I paid, and now I'm able to come back to the Hangout. Okay. So now let me take the connections, sorry, the questions. There are many things which just say lost your connection. So I'm passing all those things. So one question from Rocky is, can you explain how Spark application is designed in real-time project work on Hadoop cluster? This is not the right time. We will take that question some other time. Eventually we will have Hangouts, and we will be covering a lot more topics. And stay tuned. Follow me on Google Plus and stay tuned, and we will take care of that later. Okay. So any other questions before we wrap up? We are already past our time because of the hiccup in the middle. We lose some time. Otherwise, it is well planned for 1 hour. If you have any questions, still I will take those things. Otherwise, I will disconnect. Okay. That being said, please make sure you follow me on different platforms. And also, if you are interested to be part of the blogging and building our network, send me an email at training@itversity.com. I also have a Google Groups. So if you want me to send you the last minute reminders, if you want to get the notifications and all those things, please be part of Google Groups itversity. That is not as part of this list under Stay Connected, but you can go to Google Groups and search for itversity, and you will find mine, and you can actually send the request. Okay, or the email ID is itversity@googlegroups.com if you want to join the Google Groups. Okay, so the question from Raj, as you said, at a given time only 486 tasks or vcores can be run. No, that is not correct. So vcores are representation of virtual cores of your hardware capacity. Okay, so depending upon there are two terms here: vcores from the server side, and also vcores from the yarn and MapReduce side. Okay, so for MapReduce, in this configuration, if you have 486 total vcores from the cluster capacity side, if you give 1 core for the map tasks and reduce tasks when you run the jobs, or even as part of the MapReduce configuration, if you say map vcores as 1 and reduce vcores as 1, at any point in time, you will be able to run only 486 tasks with this value. But if the average number of vcores for each task is 2, you will be able to run only 486 by 2, which is 243 tasks simultaneously. So as I have said, the number of tasks that can run at a point in time can be significantly different based on the values which are configured as part of MapReduce configuration, and also at the time of runtime also you can override those values. So while submitting MapReduce job also, you can say for one job I want 1 GB RAM and 1 vcore, and for other job I want 2 GB RAM and 2 vcores. In that case, the number of tasks or containers that will be running on the cluster will be significantly different. Okay, the way you should design is, in this case, you should at least give one core, and then if you want to run all your tasks with one core, you should give at least 1.5 GB RAM so that you use as much memory as possible. So 486 into 1.5 will be 729. Still you will be wasting some memory, but that is better than wasting almost 1/3 of memory. So you have to determine these values to use your cluster effectively, and these values has to be determined at the application level or even at the job level sometimes. So a follow-up question from Raj. Does each core run one task like map task or reduce task? No. Each container will use. So container is nothing but a map task or reduce task. You are thinking from other side. You should from the container level, how much memory and how many cores it is using. So a container can be a map task, or a container can be a reduce task. Okay, and depending upon the configurations, it might run with 1 vcore, or it could run with 2 vcores. So it depends. Okay, and so you should think from the map task or reduce task level, how many vcores it will use depending upon the configurations which we have done. Okay, you should not think that each core will run a map task or reduce task. You have to think how many vcores and how much memory will be used by a map task or reduce task or any container that will be that is managed by YARN. Okay, another follow-up question. That's it. I will go to the next question. Even if you have some follow-up, we will come back to it later. vCore's property should not be kept final by administrator. It depends. So sometimes if they keep it open, people might abuse the cluster if developers don't have enough knowledge. So it depends upon the company policies. It could be kept as final, or it need not be kept as final. Ideally, you have to think from the scheduler's perspective. You have schedulers. You will create pools out of them, and at the application level, you have to somehow manage in such a way that not every developer play with these parameters. So you have to keep these things in mind and make sure how you can work without running into too many issues. So the question is how to restrict Spark to consume only some part of memory. Again, it is related to Spark tuning. It is there are certain parameters when you submit Spark jobs like executor memory, etc. Using that, you can actually control the amount of memory and also amount of vcores you want to use, or executor cores you want to use. And also at the parameter file level also, there could be some parameters like spark defaults.env or some other Spark related environment or parameter file will have certain parameters which you can define to override the defaults. But if you want to reset those things at runtime, you have to understand those additional parameters or control arguments which you need to pass to override these values at runtime. I will not get into too many details at this time because it is a little bit out of scope. So any other question? I will take one more question and we will wrap up for the hangout for the day. That being said, thank you very much to be part of the hangout, and stay tuned and also spread the word. We will try to come up with content not only related to big data but many other technologies over time, and also we'll be getting into staffing solutions probably second half of 2017. where we want to break the status quo in the current IT recruitment market. Okay, so the next question from Raj again is, what is configuration of nodes in a production cluster you worked on from data perspective? Again, I have already explained. I have worked on the clusters where we have ran into petabytes of storage, and I don't want to get into all those details at this time. Okay, if you want, I can share this spreadsheet with you. You can think from this perspective rather than trying to understand what clusters I have worked on before. Okay, because if I explain my cluster, it might not cover all the scenarios. So I have created this generalized content. Okay, that being said, I hope you have enjoyed the session. Please provide the feedback. If you like the Hangout, please click on the like button. If you have any follow-up questions, please post the questions in the comment section. And bye for tonight, and have a nice weekend. Bye.